In this video, we will talk about Group 28's process of the project and its individual phases. In this project, we used the Scrum method. For Phase 1, Phase 2, and Phase 4, we used longer sprints. About the individual phases. In Phase 1, we devised software ideas and drew pictures for visualization of the software. In Phase 2, we went further into designing our software. We designed a use case diagram, a CRC diagram, and a UML class diagram. And we determined the functional and non-functional requirements of the software. And we created a test plan for functional testing. In Phase 3, we used shorter Scrum sprints, with each sprint taking from 3 to 4 days to code the software. And we created a complete demo of the software. And we also created a video to showcase the complete demo. In Phase 4, we created a testing report for the software, and we created a final version of the UML class diagram. This is the end of the introduction. In the next part, we will discuss the project phases more in detail.
Hello, my name is David Brown, and I'll be going over our project Phase 1 overview and our use case diagram. Phase 1 is really about getting our UI design down and laying down the foundation for the functional requirements for our service. Here we can see we have the login page where users will be able to input a user ID and password, and upon pressing the login button, their information will be taken and see if it matches with our database user information. If it doesn't match, it will display that we have an invalid user, that the user is not in our database. Here we see we have the seller view, which will be the default page for sellers upon logging in, having a successful login. Here sellers will see book listing, which will list out all the books that they currently have listed for sale. On the left, they will be able to sort their books listed by either category or condition. On the right, they will be able to sell a book, in which upon entering a valid title, author, category, condition, and an original price, it will generate a price for said book, and then they will be able to either list the book or clear, which will just clear all the previous selections. Upon pressing list a book, it will officially list the book on our site. It will update our database, and it will reflect in their book listing about the new book that they have listed. Going to the buyer view, in the middle we have our grid, which will display all the books currently available to purchase from our buyer. They are able to navigate on the bottom via the navigation arrows, the different pages of books that we have. On the left, you'll be able to filter books either by category or condition. And on the right is our cart, in which users will be able to add books that they would like to purchase via the add cart button. And it will reflect on the right. It'll calculate the total price, its taxes, and the total. And upon pressing checkout, the books will then be checked out. It will update our transaction information, our database. The book will no longer be able to be listed for sale, and the user will have officially bought the book. This is our use case diagram. We can see that buyers and sellers are a generalization of our user class. Buyers, upon successfully logging in, will be able to view their book catalog. They'll be able to filter the books via the category condition. They're able to add books to cart, and upon satisfied with the books that they have selected, be able to check out, which will update our transaction data. Our transactions will update our book database and reflect by showing that the book is no longer available. Sellers, we can see upon successfully logging to the seller page, we will have an overview with our book management system, which will be able to sort and filter books. You'll be able to view the book listings, and they will be able to sell the book, which will update in our database that a new book has been added and officially be able to be bought. That is our Phase 1 overview and a summary of our user case diagrams.
For object identification in CRC, we determined that our objects were the seller, buyer, and the admin, as well as books, transactions on our database. This is what our final class diagram looks like. Each of our login, buyer, seller, and admin pages would be generic scenes in JavaFX. In order to switch scenes, we would have to utilize the Scene Manager class by providing a string that corresponds to the scene type. Our database ended up being an SQL database, so we created a database class that would allow us to craft generic and complex queries. These methods would insert, update, or select user, book, and transaction information. User, book, and transaction were also their own classes. This allowed us to more easily manipulate and update these objects to the database. Each user would first start at the login scene, where they had to provide an ID and password. Then the login scene would verify the info using the database. The scene manager would then switch to a different scene, depending on the role of that user. In the buyer scene, books were displayed in a grid pattern, so each book cell would have to be created using the createBook method that returned a VBox object. The grid also had to be updated using the refresh method, which would query the database depending on the filters set by the buyer. In the seller scene, books were displayed in a table. The table also had to be updated using the refresh table method, which would query the database depending on the filters set by the seller. The last thing to note about this diagram is that the book system contains information about the sales tax, discount rate, and the category and condition rate. In our test plan, most of our test cases passed, but we failed 2 cases. In the seller scene, when listing a book for sale, the data fields would not clear after clicking the List Book button. In addition, we ended up having no way of removing a book that was already listed.
So now we're going to be going into the main modules of our code. First thing we got to think of is our scene manager. This is one of the bread and butters, or I'd say one of the 2 backbones of our system. We needed a way for scenes to transition between scenes without a scene having a reference to every other scene, and vice versa. So what we ended up doing is we have this thing where we have a scene manager that has a hash map of all the scenes, and at any moment a scene can call the scene manager and swap to a different scene just by providing it a string. This saves on memory, this saves on confusion, and it makes everything a lot more streamlined. So in our scene manager, we do have a generic scene class, which is the next thing we're going to talk about. Basically, generic scene class is what we use as a base for all the classes. We knew that all of our scenes were going to be same in some regard, but we just didn't know how until we made a generic scene class. So everything has to be 1280 by 720. It has to have a scene manager I can call to, and it has its own methods like initialize scene and refresh tables. Refresh tables basically just has to do with keeping track of when we update the database, we want to update what we're currently seeing that we already preloaded onto the screen. So we want to refresh that so it matches the database again. We're seeing there's not a lot of interesting stuff that has to do with that, but we do have checkout books where we need to cycle through every single book and make a new transaction for that book and then immediately update that transaction inside of the database so that we now know that this is sold to this person at this very specific date. Creating book, this is just a way for us to list books right on the screen. Each page is about 25, and you have to keep track of those 25, because if you don't keep track of the 25, then you're going to go having infinite pages of just nothingness, because there's nothing to pull from the database at a certain point. So what we ended up having to do is we learned about offsets with SQL, so that helped quite a bit, and then simply just checking if the next query you're doing has less than 25 books, which is our limit. Then you want to disable everything for letting you scroll even farther on. This query command basically allows us to filter the results of the buyer scene. If you want a book that is math and heavily used condition, we can do that. We just simply make a live query, which isn't that difficult to do. This is the actual query itself, select from books where, and the command is where categories equals whatever you have selected in the buyer scene, or condition is equal whatever you have selected in the buyer scene. ordered by ID, limit, etc., etc., etc. When it comes to this other thing, the most important things we need to look about is listing books. So basically, we have to, anytime you list a book, we have to pull all the information we were just given, add into the database, make a new transaction for that, and then after that, we also have to keep track of the date that we're currently in because we want to know when we listed that book. But we also have to try and figure out if the ID we're using for the transaction in the book are new IDs or if they're already used in the system. That's what our database handles here. Quite simply just database.generate unique ID for both of them. And it works fine. Our database class, this allows us to have our database at all. It makes things so much easier when you can start everything in a SQL database and then pull. You can pull stuff and then immediately make those into objects that then you can morph with Java all you want, and then you send those objects as objects back to the database, and it works perfectly fine. So this is just creating the database, simply just adding a bunch of books into it. Get user ID. We go get the user based off the ID that we provide to it, and then we make a new user object that then we can return to whatever whatever scene is going to be using this, basically. Get books the same way. Get transactions the same way. Just return a transaction object, Get book category. This is actually decently important for knowing. Get book category was originally what we're using for sorting along with get book condition, but the problem is that if you want to have both at the same time, like we had wrote about, then you have to create another function, which is simply get filtered book list. This is where we make this long query where it's like select from a book where we want to find a certain ID in, then we want to select a book ID from our transactions where we want to then keep going down and down and down to find a specific category and condition, etc., etc., etc. And then finally up here we have get listed book. This is a very important seller function. This is just trying to get what books they currently have listed. This is used for refreshing constantly every time they add a new book. Because without this, a seller wouldn't be able to know what books they have sold and haven't sold if they were able to pull and see the books they have listed. That's about it for the code modules, and I'm just going to pass it on to Koa for the conclusion.
About the conclusion, to wrap up this video, I have some observations. About the quality of the final product, the software is functional to the customer's minimum requirements, but it didn't fulfill other requirements, such as implementing Adminville. The software has satisfied basic performance, but it has rather limited optimization for scalability. And the software also has implemented basic security, but it is limited. The software has good code readability and documentation, and the software also has good code modularity and reliability. In the end, the software has passed a good majority of the testing report, but the software has failed several points. About teammate cooperation, we have some good points. We effectively followed the Scrum method, and we were quick to integrate and adapt to different people's code. About the flaws, there was confusion and overlapping and splitting technical tasks, and there was uneven technical knowledge among teammates. About the things to consider, about teamwork, we should have more specific planning for the code, and we could have more code modularity for easier integration and adaptation of different people's code. And we should have more exposure to new technologies and programming knowledge for more unique capabilities. And we should pay more attention to technical aspects, including software architecture, code reliability, code performance, and software security. This is the end of the video, and thank you for listening.